Now, what we have to achieve using service virtualization? When I will identify a particular framework or a tool, what I need to look for. So when we are virtualizing or when we are adopting service virtualization, you need to ensure that you are able to isolate your test object from outside dependencies. That's what is the first thing. And how do we deal with this? We deal with this by using mocks. We'll be using mocks. Now, what are these mocks? Mocks are dummy implementation of objects or dependencies, right? For which you can go ahead and define the behavior and the output it generates when you write your test. So by using mock instead of real dependency, you get full control over what output from a dependency goes into your component when you are testing it. That's what is first task. So I will be doing what? I will be identifying that, okay, what mocks I have to build in order to ensure that my tests are not dependent. And when I'm defining mock, I need to clearly understand and also specify behavior and the output that that particular simulated or mimicked or mock generates when we write the test. That is what is the first objective as a service virtualization engineer is what we have to take into consideration. Then comes, okay, I understood that I have to go with mocks. I have to go and identify dependencies for which I will be creating mocks. Second is you need to also understand and identify how do you simulate dependencies which are not in your control. So how do we do this? Because when we talk about dependency, there are certain challenges when actually we want to incorporate the behavior of component in the test by using mock or by using stub or by using whatever, right? Now, first challenge that these components which are dependencies will pose is they're not available on demand. It is very hard to set up the right test data in the component. Not only that, you're simulating. And believe me, it is very difficult to simulate error cases in those components. For example, if you want to simulate, you say 503 service unavailable from a service you invoked, but you don't control it. Simulating will be difficult. So to take care of that, what we do is, apart from service virtualization, we use stubbing. Now, both these techniques, stubbing, virtualization, will help us to create our simulations. And those simulations that we create mimics the behavior of the platform, and that is what can be used for end-to-end testing. So when we are using simulations in our integration and end-to-end testing, there are certain benefits that we get. First is we'll be able to test early. Second, you'll be able to test more. Third, you'll be able to test often, and that is what should be our test strategy. Test early, test more, test often. So once this strategy is derived, it is derived as a result of you identifying the right mock objects which are not part of your system. You're able to identify right stubbing, which is not part of your system, and you are able to create most suitable simulations in order to use them in your integration and end-to-end tests. Now understand one thing. Sometimes, when I go through certain frameworks, I really get confused about these two terminologies, stubbing and service virtualization, because they are not well demarcated. When you will read theory behind them, you'll find that they are talking about similar thing. But understand, when I go and virtualize service, in layman terms, I need to identify mock, I need to identify stub, I need to see how well I'm able to simulate the behaviors on which my tests are dependent for the current component that I'm testing. Our strategy should always be to test early, to test more, and to test often. So if your mock and if your simulations are actually helping you to do all these three, which are part of your strategy, means your stubbing and virtualization is fine. So this is what is about what actually we look for when we are planning for service virtualization. Any confusion? Because this is important. What you will be doing is this. So I'm sure that now you are aware about what is objective of service virtualization. You are aware about what you need to do for service virtualization. But without understanding service, you will not be able to identify the components which actually you have to simulate, mimic. So it's not only knowing a framework, but it is also about how well you are able to identify the dependencies and then derive a mock out of that dependency. And then comes the framework. Okay, I'm using framework A. Framework A tells me to create mock using this, then create stubs using this, and then apply stubs and use stubs while we are testing in this particular way. So we need to understand the service itself. And let me talk about what happens when we talk about identifying appropriate component. You might have heard about microservices. They are independent. And when you adopt microservice patterns, you have to go through how I will be managing persistence, how intercommunication will be there among microservices, how to take care of a microservice if it is down, right? So these reflects various different frameworks. So microservice, if you're testing, your stub and your mock identification will be driven by primary objective of that microservice, that is functional. Apart from load, apart from stress, apart from availability, there are multiple different reasons why actually you will be testing it out. So if I say, if I'm planning to test my service, which is built using microservice architecture, you need to find out how these services are communicating with each other. So for that, you need to often test end to end how a service communicates with other service. Now, why I'm saying this, please understand. See, one of the requirement is to test end to end how a service communicate with other service. Believe me, mocking will not help you here, because mocking is not the solution for test end to end test and how service communicates. In short, it does not test the communication stack. It will skip every time, specifically related to network protocol. So running the dependent service is not an option because of the effort that is required to prepare the process each time. So here, independent mocking fails. See, your service virtualization implicitly will be using mock, but when I talk about mocking, it's just mocking a component without implementing features which are required to recognize it as a service. So whenever your need is to test end to end how a service communicate with other service, best candidate is service virtualization, because service virtualization is the technique that will help you to simulate the behavior of dependencies of a service by enabling you to create a proxy service. So you don't need to boot the real service again and again. And there are many frameworks which helps you to do that. So this is what is one of the differentiation that I told you. Interconnected services, you have to go and test. End-to-end testing, service virtualization is key. Now let's go and understand the structure of a service. What actually a service is. A service is representation of a task, a decoupled task, a task which can exist independently. But you'll find that implicitly all the services are dependent on some dependencies. For example, most of the business services will be backed by a database. Every service there must have its own set of tests to validate its correctness. Now, if you are trying to plan your test, you need to be aware about what all are the components which are implicitly contained in a service. And here you can see the diagram which actually tells you in form of layers. Now, if you are aware about REST, think resources. Resource is an object that actually is used in order to derive a service. For example, in employee management service, employee will be a resource. In hospital management service, patient, doctor, all these are resources. From perspective of service, resource acts as an entry point to the service. What they do, they unmarshal messages that comes in form of any protocol. They validate that the input parameters are valid. Then they transform domain object, and create a response. So basically, when I say resource, it's a RESTful service which will have an URI. You can invoke that particular service using URI, and you can do your create, read, update, insert, delete operations. You can use multiple different data formats like JSON, XML, Evro, Parquet. There are different formats in which you can represent a resource. Then comes second, which is critical. It's business. You have the resource now. You need to apply business logic where your business rules of service is what is specified, like persistence logic and others. Then comes the third part, which is persistence. Now, this is the place where actually your resource objects are persisted in backend, which can be SQL or which can be NoSQL. If you're from Java background, I'm sure that you might be connecting with me because resource is REST, which is implemented using JAX-RS. Business is business logic. It depends whether you're going with distributed business logic or what kind of business logic. So you can use EJBs. Persistence is implemented using JPA. And then comes the gateway. Now, what is gateway? Gateways are typical layers of your distributed architecture. It is gateway which encapsulates all logic to communicate from a consumer service. So you can say that it is gateway which provides service. Marshals, unmarshals operations between the underlying protocol and the domain objects which are involved. So you can say that I'm using API gateway to which client connects. It makes call to an endpoint URI. Depending on the URI and the structure of the URI, it delegates responsibility to invoke a business logic. And business logic in turn can use persistence layer for either getting data from a database or putting data, deleting data, whatever operations you are doing. Right? So these are critical components which actually you will be using or you'll be engaged in testing. For example, my persistence layer is yet not ready. I'll go and I will mock it. My gateway business logic layer is not yet ready. I'll go and I'll mock it. Resource is representation of a particular entity to which multiple operations are binded. So whatever is dependency in order to produce required outcome, when I target a particular URI, I will go and mock it. So you can say you can test the top layer, which is right out of gateway layer. Top layer is resource. You can test it by mocking your assets. So I can go and I can mock gateway. For example, all these are dependents. I will mock gateway where I will specify input and output, and I will be able to test my service if it is dependent on service which was built using these components as part of layer. So you can say if it is a dependency, I can go and I can mock my gateway. So this is how you will be able to identify what you need to mock. From perspective of API, service virtualization can be considered as a technique that helps us to simulate the behavior of dependencies of a service. Now, if you see, everyone is talking today about REST, even microservices. So you'll find that service virtualization actually is associated with REST API based services. But yes, you can, apply it to other dependencies as well, like your EJBs, JMS, or any other non-REST protocols. But understand, your tool must support it. So this is what, we need to keep in mind before we start talking about creating mock objects and start utilizing service virtualization. But let's move to something, and that is, why do we need service virtualization? Core reasons of service virtualization. See, service virtualization no doubt helps in testing internal services. But sometimes it also helps you to test services that are not in your control, and that's the objective. Some of the scenarios when actually service virtualization can be one of the candidates are: your network is down, so you are not able to communicate with external service, virtualize. External service is down and you get some unexpected error, which is correcting that error is not there in your hand. Limit on the API. Some public API have some limitations, that is rate per day. And if you reach this level, then your test will start failing. So with service virtualization, we can go ahead and we can avoid all these scenarios. And you can clearly see that your service A is making call to virtualized service B, where virtualized service B responsibility is to do actual task. You are just mimicking or simulating that particular task. So if you think about how you have been testing components specifically in monolith architecture, you have been using similar things, right? But approach was mocking. So when using mocks, you are simulating the behavior of an object. Using service virtualization, you are doing something similar, but instead of simulating behavior of an object, you are providing solution of a remote service. And this is the reason why in certain companies, service virtualization is also termed as mocking for enterprises. So this is how you'll find that service virtualization can be one of the candidates. For example, you can see the diagram. In this diagram, you have a case where communication between services is happening through HTTP protocol. Hence, you will have an HTTP server whose responsibility is to consume the request from the gateway class and provide the outcome. And that's what is happening. So you are able to test your service, which probably is dependent on other service, which is not yet ready, or there are some reasons why you are not able to use the actual concrete service. So you can go and you can virtualize it.